Hello dear students, so now today we would move ahead in this first chapter of class 11th mathematics, that is sets. So let's discuss some new sort of questions here today. Question is, which of the following are equivalent set? Equivalent means the cardinal number of both the sets should be equal. Cardinal number already I have told you, mean the number of elements. If the number of elements are same in both the sets, then you would be calling such sets as equivalent set. Okay, so in the first case, let's check the cardinal number of set A and set B. If you see the cardinal number of set A, that is Na, is how many elements are here? 1 2 3, so 3 is the cardinal number. And if you see the cardinal number of set B, so again you have 3 elements there. So we have the same cardinal number here, isn't it? Same cardinal number. So hence set A and B are what? Are equivalent sets. You will be calling set A and B as equivalent set. Why? Because both the set have 3 elements, isn't it? Now let's move towards the next question. You have set C, and the set C contains the natural number, and the natural number should be less than 3. Means all the natural number which are less than 3 that you have to write. So I can write 1, I can write 2. Only 2 elements would be here then, isn't it? It can contain only 2 elements, isn't it? Because we cannot take 3. Only the element less than 3 we have to take. And the natural numbers are starting from 1. So 1 and 2, these are the 2 possible elements there in the set C. Now let's check the elements in the set D. The set D contains the whole numbers here. And the number should be less than 3. X should be less than 3. So all the whole numbers less than 3, whole numbers are starting from 0. Just remember this. So 0, 1 and 2. So these are the 3 elements here. Now if you see the cardinal number of set C, so you have 2, because 2 elements there. Now if you check the cardinal number of set D, so you have 3 elements here, isn't it? So the cardinal number is not same, isn't it? Cardinal number of both the set is not same. So hence what? Hence set C and D are not equivalent set. Now let's check this one. You have set E. Check the cardinal number here. How many elements are there? 5 elements. Check the cardinal number here. How many elements are there? Again 5. So both are having the same number of elements. So again you would be calling set E and F as the equivalent sets. Okay, just note it down now. Now we would be moving towards the next question. Question is, state whether the following are finite or infinite sets. Okay, so we have to find. Okay, so first one is, you have a set A, and this is the set of all triangles in a plane. Let's say this is the plane. So how many triangles you can form here? How many triangles? I can form here infinite triangles. Infinite triangles, isn't it? So in a plane, the number of triangles are not finite. In a plane, let's say this is a plane. How many triangles you can form here? Infinite. Okay, means it never ends. It is never ending. Keep making the lines, keep cutting the lines, you would be getting the triangles. Okay, so it means what? It means in a plane you have infinite triangles. So this one set would be an example of infinite set. This is infinite set. Okay, now the next one, set of points on the circumference of a circle. Let's say you have a circle and this is the circumference. So on the circumference, how many points could be here? How many points could be here on the circumference? Infinite. Can you count all the points? No. Okay, so on the circumference of a circle there are infinite points. So that is why the set B is also what? Infinite set. Okay, now you have a set C, and it is a set of all lines parallel to the y-axis. You have the 2 axes. This is x-axis and this one is y-axis. So how many parallel lines you can draw? This is the y-axis. So along the y means you have to draw all the lines which are parallel to the y-axis. So I can draw infinite lines. Look here. These are all the lines which are parallel to the y-axis, isn't it? So how many lines could be there? Infinite. Okay, so again the set C is infinite set, isn't it? Okay, this is also infinite set. Now next one, that is, you have set D, and this is a set of all leaves on a tree. Now one thing let me tell you, finite means it ends somewhere, and infinite means it does not end somewhere. If it does not end somewhere, then you would be calling such set as infinite set. Now let's take this one example. You have set D, and this is the set of all leaves on a tree. So all the leaves on a tree are ending or not ending? I think ending. But the amount of leaves would be a huge number of leaves would be there, isn't it? But ultimately it is going to end, isn't it? So that is why the set D would be a finite set. Why? Because the leaves are going to end. If you keep counting, you would be getting the final result there, isn't it? So that is why the number of leaves on a tree would be a finite set. But definitely you would be getting the large number of leaves there, but ultimately they are going to end also, isn't it? So that is why the set D would be a finite set. Okay, now let's move ahead. So these are few more questions that we are to discuss. Now if you see, you have a set E, and this is the set of all positive integers greater than 500. So if you are writing the all the integers greater than 500, so you would get 501, 502, 503. So are they going to end? No, they never end. You would be just moving up to infinity, isn't it? So these numbers are not going to end anywhere. Okay, so the set of all positive integers greater than 500, so this one set would be an infinite set, isn't it? Good. Now the next one, you have a set F, and this set contains the element x such that, what are the elements here? If you see, x such that x belongs to the set of real numbers. Now real numbers means this includes rational as well as irrational numbers, means fractional numbers also, and the under root 1 numbers also are there. Now if you see, the x is between 0 and 1, means all the numbers which are greater than 0 but less than 1, so all the numbers you have to write. So what are the numbers which are greater than 0 and 1 less than 1? But the real numbers you have to take. But real numbers are in the form of fraction also, decimals also, terminating, non-terminating, non-terminating, non-repeating decimals. So between 0 and 1 you can get infinite number of real numbers. Okay, so there are infinite number of real numbers between two given numbers, rational number, isn't it? So that is why this set again is going to be an infinite set. Why? Because the set belongs to the set of real numbers, and the real numbers are many. This includes the decimal also, fractional also, means terminating, non-terminating, and non-terminating, non-repeating decimal also, under root 1 number also. Getting it or not? So all the numbers between 0 and 1, there are infinite numbers there. Infinite number of elements they are there. Okay. So now let's take another example, that is, you have set G, and that set G contains all the elements. The set G contains the elements which belongs to the set of integers, and these integers are less than 1. So how many integers are less than 1? Again infinite. If you see the integers less than 1, so less than 1 means you are getting 0, less than 1, then you are getting -1, then -2, up to minus infinity. You would be moving up to minus infinity. So again it is not going to end. So hence this set, that is the set G, this is also an infinite set, isn't it? Now you have the next one, you have the set H, and this set H contains the elements x such that x belongs to the set of integers, and the integers are between -15 and 15, means the integers should be greater than -15, means it would include -14, -13, -12, then up to 0, then 1, 2, then up to 14, because less than 15 you have to take. So all the integers which are greater than -15 and less than 15. So again you are going to get the finite number of elements here, isn't it? -12, -11, -10, -9, -7, -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, up to 14. So these are the finite number of elements or not? Okay, so hence the set is what? This one set is a finite set, isn't it? Just note it down also. Now a few more questions are here. Now the next is, you have a set I, and the set I contain all the elements that are belongs to the natural number, and x should be prime. Means there are many natural numbers. So among all the natural numbers there are many prime numbers, isn't it? Are you getting? Means the x belongs to the set of natural numbers, and those natural numbers you are to take which are prime number. So if you see in the natural number, the number which are prime starting from 2, then you have 3, then you have 5, then you have 7, so it never ends, isn't it? So hence the set I is also an infinite set, isn't it? Next one, you have a set J, and this is the set of all circles for passing through the origin. This is the origin. This point is known as origin, and the coordinates of the origin are 0, 0. These are the coordinates of the origin. Okay. Now, how many circles would pass through this origin? Just imagine. The one circle is this. Okay. Another circle means many circles can be passed from the origin. Isn't it? Are you getting? Small circle also, some bigger circle also. Okay. Now if you see the number of circles which are passing through the origin, hence again you would be getting the infinite number of circles that are going to pass through the origin. Are you getting it or not? Means all the circles has to pass through the origin. Means let's say this is the circle and this passing through origin. Look, this is the origin. Okay. Now one more circle you can make. Again some smaller circles also you can make. Here also. Means many circles I can make, isn't it? Many circles. So the number of circles which are passing through the origin, so hence again you would be getting the infinite number of circles there. So hence again the set J would also be an infinite set, isn't it? So that is all for today. Would be discussing some more questions in the upcoming lectures. Till then, stay tuned and keep watching. Thank you. Have a good day.